Let's understand circles in this video. Have you noticed round shapes everywhere? Like the sun, a coin, or a rippling drop of water? Today we will see what a circle really means in maths, using simple words and examples. A circle is all points on a flat surface that are the same distance from one fixed point called the center. The distance from the center to any point on the circle is the radius, and a diameter is a chord that goes through the center. Remember, diameter equals 2 times the radius, so it is the longest chord of the circle. A chord joins any 2 points on the circle, and an arc is a part of the circle between 2 points. A minor arc is the small part, and a major arc is the big part. Locus is a set of points that follow a rule, and concyclic points are points that all lie on the same circle. A circumcircle is the unique circle through the 3 vertices of a triangle, and its center is the circumcenter, found where perpendicular bisectors of the triangle meet. In an acute triangle, the circumcenter lies inside. In an obtuse one, it lies outside. And for a right triangle, it lies at the midpoint of the hypotenuse. A circle has special symmetry. You can rotate it by any angle and it looks the same. And every diameter is a line of reflection, so it has infinitely many lines of symmetry. If I give you 2 points A and B, many circles can pass through them. The centers of those circles all lie on the perpendicular bisector of AB. But if 3 points are not in a straight line, there is exactly one circle through all 3. The perpendicular bisectors of 2 sides meet at the single center. Equal chords in a circle subtend equal angles at the center. And conversely, chords that make equal central angles are equal in length. The line joining the center and the midpoint of a chord is perpendicular to the chord, and conversely, the perpendicular from the center to a chord bisects that chord. The distance from the center to a chord means the perpendicular distance, and equal chords are at equal distances from the center. If 2 chords are at the same distance from the center, they have equal length. And if one chord is longer than another, it sits closer to the center. A useful formula ties chord length to distance. Chord length equals 2 times square root of r squared minus d squared, where r is radius and d is the perpendicular distance to the chord. Now about angles. The angle an arc makes at the center is double the angle it makes at any point on the circle away from the arc. For example, if the central angle is 60 degrees, then the angle on the circle that looks at the same arc is 30 degrees, and a diameter makes a right angle of 90 degrees at any point on the circle. Also, all angles standing on the same arc on the same side are equal. That helps find many unknown angles quickly. If a segment AB makes equal angles at points C and D on the same side, then A, B, C, and D lie on one circle. They are concyclic. In a cyclic quadrilateral, opposite angles add up to 180 degrees, and the converse is true too. If opposite angles add to 180, the quadrilateral is cyclic. So, what do we learn from this? Circles have neat rules linking chords, angles, distances, and symmetry. And these rules help us solve many geometry problems. Let us quickly remember. Center, radius, chord, diameter equals 2 by radius. Arcs, equal chords equal angles. Central angle is double the inscribed angle. And cyclic quadrilateral, opposite angles sum to 180 degrees. Keep exploring diagrams. Draw perpendicular bisectors and try small examples. They make these ideas clear and fun. Good job listening. Keep your curiosity alive, stay confident. And if you want more practice and clear notes, do explore more on EduRev to learn at your own pace.